Okay, so this is the first lecture or first review of the Head First SQL book. And if you're just starting Head First SQL, you probably are just getting into databases and you might be wondering why we use databases. Maybe not. But essentially, it's just used to make life easier. Like a lot of things in computer science, databases are a metaphor for real things, just like we have folders and files and desktops that are metaphors for the real life things. Databases, usually records, are what we call each table, and they store information that maybe we used to store on things like they show here, like we used to store on sticky notes, and it standardizes this data. There are best practices that make it even more searchable, and it makes it so that we can use data and analyze it and make web apps that utilize databases. And so hopefully this is enough of a motivator, especially if you're already in the industry, to want to learn a little bit more about how to use it. Now, SQL is a relational database. There are a lot of other ones that are not. SQL does not support non-text objects, whereas you have NoSQL that does. SQL, I think, is probably still the most used database language, although a lot of companies have their own little proprietary things that are faster, most likely, but they also cost money. SQL should be good enough for pretty much anything that you're doing right now. And so, without further ado, SQL tables, we tend to structure them just like you'd structure notes that you're already taking. You make logical names for columns in your table. The columns in a table are also called attributes. And we have rows in a table, so you can have like a record count of 90, which would mean you have 90 rows in your table. So, just to visualize this, this is what your SQL table might look like. Of course, it can be much more complicated than this, but this is a very basic example of a SQL table. One thing you might notice is that the column names are somewhat standard. You can't use spaces, you can't use special characters, but as you can see here, the authors chose to use an underscore to represent spaces. And it's in a pretty logical order. You don't have a bunch of crazy long names on here. So the basic structure in SQL is you have your sort of uh, overlord database, and that's usually represented with one of these little pie looking things. And the database holds tables. So you can't really directly query a database other than you would say use and then the database name. But after that, you have to query tables for information. So a database could have multiple tables, but the data is stored in tables, not directly into the database. And here's a little bit better of an explanation of what I was trying to say. You have your database diagram here, and then you have a bunch of tables. Each table has some columns, and each column has some data in it. And if you have the book, I would highly recommend doing these exercises, especially if you don't have any experience or your experience is very limited. So to start out with SQL, you would need to have a database management system. That's what the acronym stands for, RDBMS. That's Relational Database Management System. you'd have to create a database, and in this case it's just create database Greg's lists. One important thing to note is that it's not case sensitive. The name is. The name is case sensitive. But SQL keywords or these create database, that is not case sensitive. In most cases. Relational database management systems can vary. Some of them are a little bit more picky than others, but it's very likely that will not matter. Once you make your database, you have to tell it that you want to go into your database. And again, you have a keyword for that, which is use. So you would say use and then whatever database name you just made right there. And this is for standard SQL. It varies for like PostgreSQL and other variants. So again, to get started, you say create database and then use and then the database name. After you make your database, you have to make a table. A database is pretty useless if you don't have tables. You can just look at your database, but it will be totally empty, and that's really sad. So that's why we want to add some tables to it. And here's an example. Again, you have some keywords here, and it's best to memorize these very common keywords. There's some less common ones that are totally fine to have to look up, and nobody would memorize them unless you're a database guru or something. But these are pretty standard, and you'll likely get to memorize them just by working with SQL, and that's why it's very, very important for you to try these out rather than just read the book or listen to people talk about it. So we have our syntax here. We have our keywords create table, then whatever name we want. Again, no spaces. We use underlines for spaces, and probably I would not use camel case with this. Camel case is more like variables in programming languages. These usually you don't see camel case, so I would steer clear of that. And then in parentheses, you have the names of your columns of your new table. So in this case, we're making a table called donut list, and it has two columns. One is donut name, and one is donut type. And this is a really bad table. This is just like an intro table. This is not something that is a good table to make. And we can go into that later. But you have the name followed by the data type. And varchar, varchar, or whatever, that stands for variable characters. And you're saying that you can have up to 10 variable characters. So your donut name could be like jelly, and that would be JELLY. So that would be 5 characters, and that would be allowed. Your donut type could also be jelly, but it could be only up to 6 characters, and that's a pretty strict setting. It'll truncate anything after that, so you want to make sure that you have enough space. And you might say, why don't I just make this extremely long so I don't have to worry about it? And the answer to that is that memory is reserved once you make it. And so if you know that you're going to only make short records, then you should only use short column widths like these. And as you can see, just like any other programming language, well, not any other, not like Python, but like many modern programming languages, we end everything with a semicolon. And when you're making multiple columns in a table, you use a comma here between each one. Okay. Here's a more in-depth table creation. And as you can see, varchar is not the only type here. You have your name and then type, and that's how each column is set up. And the book gradually goes through them. As you can see here, they're introducing date, which is sort of a varchar, but it has specific regular expression requirements. And there are some other ones, especially numeric data types, which I believe the book goes over pretty soon. Okay. So another data type is decimal. And the syntax for that is, it looks just like varchar. It's just DEC, and then in parentheses you have a number, comma, number. And this comma you can think kind of as the decimal point. And so it's saying 5 numbers can fit before the decimal point and 2 can fit after it. And they have examples here. And again, I highly recommend that you read the book and you try these exercises because they're very helpful. You have integer, which is int, char, which is sort of like varchar. Like in this case, you have char1, so that's just one character, and that's usually used as like a boolean or something like that. You also have a DateTime one, which looks just like this. It's a timestamp in a specific format. And again, you'll get used to using the ones that you have to use for your job or class or something. The one that we didn't hit on yet, I believe, is blob. And blob is kind of like anything goes. It's a little bit like if you use PostgreSQL text. A little different, but overall, that's what it looks like. So after you've made your table, without knowing how to use select statements yet, you can use describe to see the structure of your table. And like a lot of things in SQL, describe is shortened. It's just DESC and then table name. So putting that in for a table that you make, you can see it outputs this. And it'll give you your list of columns, the type of each column, and then you have this column called null. So what is null? Because obviously we don't want all of our columns to have null data. So it doesn't mean that everything is null in it. And SQL null means something that's a little different than a lot of languages. It actually means that you can have a null value, or when you insert data into it, you can just ignore that column and it'll be totally fine. The value will become null. It doesn't mandate that the value is null, but it allows it. And if we had any no's here, and somebody tried to insert some data that did not contain any valid data for that column, you would just get an error and you wouldn't be able to do it. Now, key we'll get into a little bit later. And default and extra we'll get into later. And I would recommend doing these magnet things. I know it looks kind of stupid, but it does help if you don't have experience with it. It gets less important to do these. They do get a bit pedantic as you go on. I think that everybody sort of knows themselves enough to figure out what they want to do and what they don't. Now, once you've made your table, if you decide that you totally screwed it up and you just want to start over, you can easily do that. You have the keywords drop table, and then you put the table name, and it will completely get rid of the table, and maybe even more importantly, it will destroy all the stuff that's in your table. So you have to really make sure that you really want to get rid of everything in that table, because you will not get a second chance. There's no recycle bin or anything like that in SQL. Okay, so once you've made the table, if you want to put stuff into it, you can use the keyword insert into. And again, the syntax is a bit arbitrary. It's best to just learn it. So we have insert into your table, and then to separate the column names to insert into and the values, we have each in parentheses. So your table, and then in parentheses you have like column name, the second column name, and then you put values, and then in other parentheses you put what to insert into it. Now, one especially important thing in SQL, which becomes more important when you actually integrate it with web apps, is the quotations around strings. Now, some values use quotes, some don't. Some optionally use quotes. In this case, if it's something like date or blob or varchar, you put single quotes. So like you can see it's apostrophes around each one. You do not put quotes around integers, decimals, anything like that. Date and date time, you do put those. I'm sorry, I'm saying quotes. I mean apostrophe, these single quotes. Date and date time also would take these single quotes. And just one shortcut here. If you know that you're going to be inserting into your table using every column and you know it'll be in order, you can actually leave out this part. You don't have to put the column names in parentheses if they're all in order and you're inserting into every column name that's in the table with this statement. So you can just say insert into your table values and then your values. You can totally leave that out. Okay, so we'll just look at this one really fast, just to show you the usage of quotes and stuff. As you can see, this one, they use all single quotes. It's safer to use the single quotes than to not if you're not sure, but most things that aren't numbers do take these single quotes. And as you can see, here's an example that uses numbers, and we do not have those single quotes there. And these error things are a good thing to do on your own. It just takes a little bit to get the hang of it, but it's very easy once you get used to it. Now, surprised I put this much stuff into one chapter. There's this select statement. And if you do this before you insert any data, you'll probably notice that you don't get anything back. This is the most basic select statement you could have. Select statements can become very complicated, very tedious. This is the easiest type you can have. It's select star from table name. Select means we're getting some records out. The star is wildcard or everything. And then from is the keyword, and then our table name. And as you can maybe see, I'm not sure why they thought it was a great idea to drop this in the wrong orientation, but as you might be able to see, it just dumps the table with the column names and with the data that's inside of it. And if you're interested in reading Confessions of a Null, then read the book. Another important keyword or phrase, I guess, is not null. And just as I mentioned earlier, if a column says it can be null, then somebody inserting data can skip it. And that's very bad if it's data that is crucial. And so if you were integrating this with like a web app or something, if you had optional fields on a form, like you could say like religious affiliation and make that optional, but you need the person's name, you need their email address, and so you would probably match those up with this. So if it's a mandatory field where the record's useless without that field, then you would put not null. And this is within the create table. So after you put the syntax, which is the column name, the type, then you would just say not null, and that just says the person has to give it a value or else it's not going to work because it'll screw up the whole purpose of the table without that. Okay, and this is just saying that when you make it not null, if you go back and look at your table, it will have changed our nulls to no's. So no in the described table means that that cannot be null, and this is the result of them going through and making another table that says not null for each column. Okay, one of the last things in here is the default value. Now, the default value does allow you to leave out a column entry without throwing an error. And so in this case, we say the cost is a decimal. It can't be null, but if the person does not give the cost, rather than trigger an error, it'll just put 1.00 into the table. And this is particularly important for if you want some smooth operations and you know people are going to screw up data entry. And so this makes it so that you can continue on. The data might be erroneous, but at least it's not null. And it's very important for it to not be null because we said it cannot be null with this command up here. Okay, so that's the discussion for chapter 1. It's a lot of data to take in the first time you're starting your databases, and my advice is that just remember that it's a little tedious. It's kind of a pain in the ass, but it is something that gets very easy as you do it, like most things in computer science and math. And so I would just suggest that you give it a little bit of time, especially in the beginning. I would go through and I would do these exercises just to get familiar with it. And once you're done with that, maybe even set up a SQL server. There are plenty of free web hosts that'll let you do this because it's just practice is key with this. You can read books all day and you won't be able to do it if you don't put in some real time just trying out these commands and getting output and adjusting them. So with that, I will see you in the second lecture.